Assalamu alaikum. Well, let me recall the last topic which we have covered. It was related to synthesis of aldehydes, synthesis of ketones. We have carried out synthesis of aldehydes by Clemmensen reduction and synthesis of ketones, aromatic ketones by Friedrich-Crafts acylation reaction. Now today I am going to discuss about Clemmensen reduction. Clemmensen reduction, actually it is the name, it is Denmark scientist, Denmark chemist. His name is K.C. Clemmensen. He has given reduction of carbonyl group in aldehydes and ketones, both two alkanes. So carbonyl group to alkanes using zinc mercury amalgam in concentrated HCl solution. So here what we are doing, carbonyl group will be changed to alkane hydrocarbons by using zinc mercury amalgam and concentrated HCl. Now this is for both aldehydes and ketones. Let me give you first the simple mechanism, general mechanism of the reaction. Then we will take aldehyde, we will take ketone. Accordingly, we will see how this mechanism is working out, how we can, because it is not easy job to reduce this carbonyl group and produce alkane. So let me show you the stepwise mechanism of the reaction. So let us show the mechanism, general mechanism. This carbonyl group, in presence of zinc mercury amalgam, concentrated HCl solution, it is giving, so we can make here two hydrogens. Now stepwise mechanism. Step number 1. What is happening? This concentrated HCl, you know, it can give HCl, it is giving H positive plus Cl minus, because it is under acidic condition, acidic medium. So whatever H positive, whatever we will use in this whole mechanism, they will come out from HCl. Now step number 1. Take this molecule plus this H positive. Okay, so you know oxygen has electron pair, electron rich. It will attack on this. It will produce so there will be positive charge. Oxygen with positive charge is highly unstable. It is just trying to rearrange or break this bond. It is forcing this bond to break down. It is going like this way. So it is producing now we have this positive charge over, we have positive charge on carbon. This is carbocation formation of this molecule. This is step number 1. In step number 2, this zinc metal, it is undergoing through oxidation. These two electrons are attacking on this carbon, carbocation. So in second step, it will continue. Let me show you like this. And these two electrons, they will attack on this carbon. You know carbon has 4 valency. So these two electrons, when one electron is coming here, carbon is satisfying its valency, but still there is extra one electron. So because of that extra electron, there is a negative charge on this. So it will okay. Now because of 2 electrons, it is becoming here negative charge. It is becoming negatively charged molecule. So I should remove here this because this molecule is same this molecule. Now what is happening here? In the next step, again from this HCl, 2 hydrogen molecules are coming, 2 H positive. Where from they are coming? From the HCl. So 1 H positive, suppose up, 1 H positive down. What is happening? This carbon, it is attacking on 1 H positive, and you know oxygen is rich in electrons, 2 electron lone pair of electrons. It is attacking this molecule, this H positive. So what will happen because of this? 1 hydrogen will come here and 1 hydrogen will attack with this. Positive charge will come here. Now after this positive charge, now step number 3. This molecule, if I will bring it here, we have H here. You know, if we have oxygen, this is a good leaving group. This bond will break now. It will release water. Okay. So because of this carbon will get positive charge. Hydrogen is here. This carbon will get positive charge. Because of it is positive charge, now again 2 electrons. These electrons are coming from where? These electrons are coming from zinc. So in this again 1 electron, these 2 electrons, they will try to attack on this carbon. There is formation of this molecule. So 1 electron will satisfy its valency, 1 electron will be extra. So out of 2 electrons, 1 will satisfy its valency, 1 will be extra. Now here what will happen again? There will be protonation. Protonation means protonation, addition of hydrogen. This carbon, it will attack on this hydrogen. There is formation of there is hydrogen and there will be another hydrogen. This is alkane. This is the general mechanism of the reaction. So you can show these two hydrogens here at the end. If you will not show, still it is same. So now this is step number 1. Step number 2, zinc will give 2 electrons. In the third step, you can use this molecule, and again there is release of water molecule. Again 2 electrons will come, they will attack on this carbon, and there is formation of this alkene. Now I will give you one example. Suppose we will take propanone, we will take cyclohexanone, we will take methyl phenyl, phenyl propyl ketone. So when we will take some examples like that, let me show mechanism related to that. So let me take one example like this. What is this? cyclohexanone. This is cyclohexanone. So there will be attack of H positive. This H positive will come from where? From HCl. HCl, it will give H positive plus Cl minus. And also we have another thing, zinc will give zinc 2 positive plus 2 electrons. These two steps you have to keep in mind. So this is rich, it will attack on hydrogen. This is step number 1. O and hydrogen. So there will be positive charge. And you know this positive charge is forcing this bond to break down. What will be the result? The positive charge will come here. This is step number 1. In step number 2, you know what will happen here. Zinc will give zinc 2 positive plus 2 electrons. These 2 electrons, they will attack on this carbon. These 2 electrons, after attacking on this carbon, the product will be so there will be negative charge on this carbon. Okay. So after this, what is going to happen? 2 hydrogens. Keep in mind, hydrogens are coming from HCl. So suppose 1 hydrogen up, 1 hydrogen down. So we have electron pair. This carbon will attack 1 hydrogen. This oxygen will attack another hydrogen. It will result in formation of this molecule. Okay, 1 hydrogen will come here, 1 hydrogen will come here. Because of this, there will be positive charge on the oxygen. Now in step number 3, take this molecule, okay, so there is release of water. This bond will break. They will come again positive charge. So let me, there will be, and there will come positive charge. So after again in this next step, 2 electrons will come again from this step. They will attack on this carbon. After attacking here, they will give and negative charge on the carbon. This carbon, after getting negative charge, there will be protonation. H positive. Protonation. What will be the result? This carbon will attack on this hydrogen. This will be, this will be hydrogen here. This is hydrogen here. This is hydrogen. This is hydrogen. Cyclohexane. And you can, this is cyclohexane. You can write it like this also. This is also cyclohexane. This is cyclohexane. I took the example of ketone. So we have 3 steps. In first step, addition of hydrogen to this oxygen. There will be unstable formation of molecule. this molecule will try to, because of this oxygen, this pi bond will break down, it will give this carbocation formation. In second step, 2 electrons from oxidation of zinc, release of 2 electrons. These 2 electrons will help us to get this molecule. After this, we will get this. So this is step number 1. Now, if you see here, this is step number 2. This is step number 3. Let me take now aldehyde as an example. So how we can reduce the carbonyl group of aldehydes. So let me show. If I take now aldehyde, suppose aldehyde. Suppose I will take this is aldehyde. 1, 2, 3, 4. Butanol, Al, aldehyde. Similarly, this in presence of zinc, mercury and HCl, concentrated HCl, it will give us butane. Butane, this is alkane. Mechanism. Stepwise mechanism. In step number 1, so don't forget this concentrated HCl, it will give H positive plus Cl minus. We have to use this hydrogen. And zinc will give zinc 2 positive plus 2 electrons. We have to use 2 electrons. Oxidation of zinc. In step number 1, take this butanol and react it with H positive under acidic condition. So you know what is going to happen? It will attack on hydrogen. There is formation of so there will be positive charge. Now this bond will be breaking, so that positive charge will come here. This is just a canonical structure, we can say. There is hydrogen, there is oxygen, there is hydrogen. So here will be positive charge. Step number 1. In step number 2, take this molecule. Okay. It will be attacked by 2 electrons. These 2 electrons from zinc. They will attack on the carbon. They will complete first valency and they will make it negative. So there will be negative charge on this carbon. So after this, what will happen? 2 hydrogens from the acidic medium, from HCl. So suppose 1 hydrogen is here, 1 hydrogen is here. This will attack on this hydrogen and it is reached, it will attack on this hydrogen. There will be hydrogen, and 1 hydrogen will come here, and this positive negative charge will be, there will be another hydrogen. Now first this oxygen is attacked on hydrogen, so it will be positive charge. Now in the third step, this molecule, I will take it here. You know what will happen here? This water molecule will release. It is a leaving group. Okay. So it is a leaving group this will leave. It will give positive charge to carbon here. There will be positive charge. After this, again 2 electrons will come from zinc. They will attack on this carbon. There will be negative charge on this carbon. So, and also it has another hydrogen. So after this, again there will be protonation, addition of H positive. Protonation. This electron will be, this carbon will attack on this oxygen. What will be the result? 1, 2, 3, 1. And there is hydrogen, and another hydrogen will be this one. If you see what is the name, CH3, CH2, CH2, CH3, this is butane. So butanol, this is aldehyde. It has given us butane. So you can write it just a 1, 2, 3, 4. Butanol into butane. This is example for aldehydes. So we have given first general example. Then we have given mechanism with cyclohexanone as a ketone. Now I took example of butanol. Now I will give some complex example, more complex example related to ketone or aldehyde, whatever you wanted to take. It is your choice. After this, I will give you some practice exercises. Now if I take another example like this. Okay. What is this? This is ketone. So it will give us, in presence of zinc mercury amalgam, concentrated HCl, it will give us this product. What is this product? 1, 2, 3, 4 at one position, 1 butyl benzene. So this is ketone, this is alkane, 1 butyl benzene. Now stepwise mechanism. In stepwise mechanism, I will take first this one and keep in mind HCl will give H positive, Cl minus, zinc will give zinc 2 positive plus twice electrons. We have to use this H positive, we have to use these 2 electrons. Okay, in the mechanism. If I start from this compound, H positive. What will be the result? This electron pairs on oxygen, they will attack on this hydrogen. It will be like this. Positive charge will come here. Now because of this positive charge, this bond is going to break down. It will come here. Positive charge will come on carbon. This will be carbocation formation. Let me put double bonds here. Okay. Step number 1. In this step number 2, I will take this molecule now. Okay. plus 2 electrons. 2 electrons from zinc. They will attack on this carbon. Okay, here will be minus charge because of these 2 electrons. After this, 2 hydrogens from this acid, 1 hydrogen will be up, suppose 1 hydrogen down. This carbon will attack on this hydrogen, this oxygen will attack on this hydrogen. There will be hydrogen and 1 hydrogen will come here. This carbon will get positive charge and there will be hydrogen. And the double bond, benzene. In step number 3, this molecule will come here. Okay. Another hydrogen. It is here hydrogen. So it will release water molecule. It will release water molecule. This one will be released. What will be the product? It will release water molecule. It will bring here positive charge on this carbon. And there will be hydrogen. Okay. Again there will be 2 electrons, they will attack on this carbon. They will attack on this carbon. So there will be hydrogen and here will be negative charge. So finally, the final stage will be again protonation. Protonation. What is protonation? Addition of hydrogen. What will be the result? So 1, 2, 3, 4. 1, 2, 3, 4 carbons. And 1 hydrogen will be down, 1 hydrogen will be up. How? This carbon, it will attack on this hydrogen. So this is 1, 2, 3, 4. So if you see, it is at one position, 1, 2, 3, 4. 1 butyl benzene. 1 butyl benzene. This is Clemmensen's reduction mechanism. So we have given first a general mechanism, then I have shown mechanism with ketones like any cyclohexanone. You can take propanone. What you can take phenyl propyl ketone also. Then I have given example with aldehydes. Now this is another example. This is the mechanism. So step, how many steps? One step, second step, third step. Don't forget this. HCl, it will give H positive, and this zinc, it will give 2 electrons. These 2 you have to use in the mechanism, and mechanism is very easy. Now we will give some practice exercise. Practice at home. Number 1. In presence of zinc, mercury, concentrated HCl. Give the mechanism. Give stepwise mechanism. Stepwise mechanism of practice problems. Number 1. Number 2. This is aldehyde. you have to give concentrated HCl. Another practice problem. Number 3. Mercury concentrated HCl. Number 3. Number 4. This is aldehyde. 1, 2, 3, 4, 5, 6. HCl. So you have to give stepwise mechanism of these reactions, then submit the feedback to me through module. I will be waiting your answers. So in next class we are going to start the mechanism of Wolff crystal reduction. That is another name reaction in carbonyl compounds. So, thank you.